Probability can be used to make predictions for future occurrences by setting up and solving a proportion. So I want us to think about rolling a 6 on a number cube. How many possibilities are there to get a 1 if you're rolling like a dice? 1 out of how many different possibilities? 6. So therefore, the probability of rolling a 6 on a number cube is 1/6. So if I'm rolling it 50 times, then how many times should I be able to get a 6? Well, now I want to know how many times should I be able to get a 6? Like, how many possibilities are there going to be to get a 6 if I have 50 total that I'm doing? So I'm going to set up that as a proportion. So nothing times 6 is 50. So I can do cross products here. So I'm going to go ahead and do 6x equals 50. Then solve that equation, divide by 6, and I'm going to get x equals, and it's actually going to be 8.3 repeating. So what that means is, how many times should I get a 6? Approximately 8 1/3 times. Now I can't actually get it a third of a time, but it's approximately that. So it would be about 8 or 9 times, closer to 8 times really. When you send mail via the post office, you have an 80% of chance that's delivered to the correct location. So if 430 letters are delivered on Monday, then what's a reasonable prediction for the number of letters that are delivered to the incorrect location? Well, if 80% are delivered to the correct location, what percent would be incorrect? 20% would be incorrect location. So I want to know, what if there's 430 letters? Well, 20% is what? 20 out of 100. So that would be assuming 20 of the letters are delivered to the wrong location out of 100 total, because that's what percentage is. So I want to know how many if I had 430. Okay, so I can do this a couple of different ways. I'm going to go ahead and just make life simpler by simplifying. I'm just going to make it real easy, just like, whoop, that's just dividing by 10. So 2/10. So how many times does 10 go into 430? That's times 43. So what should I do to the 2? Times 43. And 43 times 2 is going to be 86. So 86 letters are going to be delivered to the wrong location. Now I could have done cross products or whatever method you prefer, but sometimes there's easier ways. On Tuesday, it's reported that 500 letters were delivered to the correct location. Based on this information, how many letters were delivered on Tuesday? So I know that 500 were delivered to the correct location. What percent is delivered to the correct location? Well, we read right here that there's 80%. So that means 500 letters has to be 80%. So, correct location, 80%, so that's like 80 out of 100. And then I want to know how many total if 500 were delivered to the correct location. So I'm looking for that right there. Okay, I'm going to go ahead and simplify this 80 hundredths. I could divide them both by 20, and that would become 4, and that would become 5. That makes it a lot easier. I'm going to do cross products because I know so many of you love cross products. So that would be 500 times 5 would be 2,500 equals 4x. Now I'm going to solve my equation, divide by 4, and that's going to get me 625. So that means 625 letters were delivered total. The table shows all the possible outcomes of rolling 2 dice. If Ashley were to roll 2 dice 48 times, about how many times could she expect to roll doubles? Well, I need to figure out how many opportunities are there to get doubles. What's the probability of getting doubles to begin with? Well, I see we have a double here, here. So how many doubles are there? 6. Out of how many possibilities are there total? Okay, well, if I look, that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's going to be 36 total different possibilities that I could get. So that's going to be 36. So think about this. What that means is if I was going to roll the dice 36 times, I should get doubles 6 of those times. So I should get doubles 6 out of 36 times. That's what probability is. So if I said, what about if I roll it 48 times? So I'm going to make it equivalent to 48. How many times should I get doubles? Well, yes, you can do cross products. You can completely do that. But I'm going to make it easier by going ahead and simplifying, because I know that 6 and 36 have a common factor of 6. So that could be 1 and 6. And then does 6 go into 48? Oh, it sure does. Times 8. So times 8. So x equals 8. So 8 times doubles should be rolled. John rolls a die and flips a coin 20 times. The results are shown in the table. If John rolls a die and flips a coin an additional 150 times, how many times should he expect to roll an odd number and have the coin land on the tail side facing up? So I'm talking about getting odd and tails. So first of all, how many different experiments did he do? How many did he do it? He did it 20 times. So that's going to be our denominator. Now I need to figure out how many times did we get an odd number and tails. So let's look at that. First of all, it has to be an odd number. So let's get rid of all of the even numbers, because if it's an even number, it's not going to work. Like, that's not what we want. So now I'm looking at the odd numbers, but what does it have to be? It has to have a tails with it. So this one, it's got tails. It has tails. That one doesn't work. That one doesn't work. That one doesn't work. Looks like I have 2 more that will work. This one and this one. So how many were actually able to satisfy what we needed? 4. 4 out of 20. So now I want to know, what if I was doing it 150 times? So I'm going to make that proportion where my total is now 150, and I'm looking for the new on odd tails. And I do want to point out, we're using our experimental probability, because this is from the experiment, not necessarily what should happen, but what did happen. Now I am going to go ahead and make life easier by simplifying this to 1/5. And then I know that 5 can go into 150 30 times. So I multiply that by 30 and I'm going to get 30. So 30 times you should get odd and tails. All right, let's see some more. Jenna flips 2 coins. The possible results are shown in the diagram to the right. If Jenna flips the pair of coins 60 times, how many times would she expect both coins to land on heads? So knowing this, look at that tree diagram. I know you love those. I can get heads with heads, heads with tails, tails with heads, tails with tails. So I want to know how many times she would expect to land on heads, both of them on heads. Well, how many possibilities are there to get heads and heads? 1 out of 4. So the question says, what if she flips the pair of coins 60 times? So our new total is 60 times. So I want to know, how many times would I be able to get heads? So I need to know, what am I doing to 4 to get to 60? Times 15. So times 15. So x equals 15. So she should expect to land on heads and heads 15 times. Now this is theoretical probability, right? Because it's what should happen. Okay, I really wanted to talk about this one. So we have a spinner being spun 72 times and the results are put into the table. So it looks like that they spun a 1 10 times, they spun 2 9 times, 3 11 times, and so forth. Now that's right there our experimental data. So really quickly, I want to talk about the experimental versus theoretical probability of each one of these happening. So theoretical probability, if I am rolling or spinning, these numbers, I should essentially get one out of 6 times. So if I was doing it 72 times, I should roll it 12 times. That's going to be the same for all of these. That's what I should get if I spun it, I should get a 2 12 times, a 3 12 times, and so forth. That's my theoretical probability, what should happen. But this is giving us the experimental probability. So let's look at that. I'm going to look at what really did happen, and it's showing me that I spun 1 10 times. So that means the experimental probability was 10 out of 72 of spinning a 1. Spinning it 2, they got it 9 out of 72 times. So that was the experimental probability. What about 3? How many times did they spin a 3? 11 out of 72. 4, 14 out of 72. 5, 16 out of 72. And 6, 12 out of 72. So that's the experimental data. That's the experimental probability. So now we're going to look at these questions. Which of the following statements is true? Out of 180 spins, the experimental data, so we're talking about using experimental here, predicts the spinner will land on 1 25 times. So let's look at what happened when the experiment with 1. We had 10 out of 72. So it wants to know, what if there was 180 times? Okay, so I want to know, is this true? So I'm going to solve it as a proportion. Now, let me kind of move over here so I have more room. So if I did 10 over 72 equals x over 180, I could go ahead and do cross products. That's 72x equals 1800. Divide by 72, divide by 72. That leaves me with x equals 25. Yes, I did that on the calculator. Okay, so that one is true. Now, we're not going to completely stop because we're just going to test them all out. Out of 216 spins, based on the theoretical probability, so I'm going to use this data, the spinner should land on 4 39 times. Well, I know that the theoretical probability says that I should land on 4 1 out of 6 times, right? So what if I had 216 spins? So now I'm going to go ahead and solve this, and when I do, I'm going to get 36. So theoretically, you should land on 4 36 times. So that one is false. Out of 252 spins, the experimental data predicts the spinner will land on 5 42 times. So I'm looking at this data right here, because we're talking about landing on 5. So this right here to see if this is correct. So our data said 16 out of 72 was what we did, how many times we landed on 5. So I want to know, what if we had 252 spins? Okay, so I can go ahead and solve that. Before I do that, I'm going to simplify, because it just makes it so much easier sometimes. Even if I don't simplify as much as I can, I know that 16 can be divided by 8, and that'd be 2, and that'll be 9. Yes, I'm still going to have to do some calculations, but it's a lot easier to do calculations with that than with the big numbers. And for time's sake, I'm not going to show you the working it out, but when I do, I'm going to get 56. So that one is false. Now we're going to look at this next one. It says out of 144 spins, based on the theoretical probability, so I'm looking at this, the spinner should land on 2 18 times. Well, I'm talking about the theoretical probability, so that's going to be 1 out of 6, and it says it should land on 2 18 times out of 144. So this is 144, and I want to know, what is that going to be? And when I do that, I'm going to end up getting 24. So that one is false as well. And yes, we figured out on the first one what the answer was, but I wanted to just practice doing these problems. Now I want you to try the ones we didn't do together on your own.